All right, there's Spartans. Let's move to these last couple here. So this is what, part 8? Part 8. Jesus, that's a lot of videos. Anyway, so here's something a little bit different. We're asked to prove that FH and JH are congruent. So if we want to go and highlight those, FH is actually this little piece right here, and GH, which I'll mark in, or JH, excuse me, which I'll mark in red, is actually this piece right here. So wait a minute, I'd have to prove sides are congruent. I've never really been asked to do that before. So how in the world is that going to happen? Well, the way it's going to happen is actually by realizing that even though I'm asking you to prove sides are congruent, the only way I have to do that is to prove the triangles they're attached to are congruent. So here's what I mean. If I want to prove that F and H are congruent, what that I really have to do is prove that this triangle, which FH, the side length, is attached to, is congruent, in fact, to this triangle down here, that JH is attached to. So even though I'm asked to prove sides are congruent, I have to prove triangles are congruent, because if triangles are congruent, then all the pieces that are corresponding and congruent in both triangles are congruent as well. So let's get into these triangles. Let's figure out which triangle congruency shortcut is going to work for me. And again, even though it's getting repetitive, here's the options. We have side, 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 angle, and angle, angle, side. So boom, let's get back to it. Well, look, in both triangles, I'm given that I have at least one pair of congruent angles. So I have these two, which are congruent because it's given to me. I know it's not stated, but it's marked in the diagram. If it's marked in the diagram, then hey, why not? Let's see, I'm also given the side length. So I have a side here and a side there, which are ultimately congruent. So immediately I have a side and an angle. So I'm not going to use side, side, side. It seems it gets used so little. And it seems to me I'm probably not going to be able to use side, angle, side. So it seems I have to find hopefully another angle to work with. But lo and behold, I do have another angle. Check out this guy right here. That's 3, and this guy that's 4. That's a vertical angle pair. So we have a second angle to work with. So I'm actually going to be able to prove this by angle, angle, side. Angle, angle, side. All right. So let's get to this, because if I can prove the green and red triangles are congruent, their sides have to be, meeting the burden of proof. So we have to prove this by angle, angle, side. So let's get to angle 1, angle 2, and side 1. All right. So angle 1 seems it was actually given to me. It looks like they're marked as angle 2 and angle 1, so I'm just go ahead and use those markings. Angle 2 and angle 1 are congruent because it's actually given to us directly. I'm going to jump to the side at the end because those were actually another given. I have FG on top, congruent to JI on bottom, because it's simply been given. And it seems like the angle in the middle is going to be the tough one, but it's not too tough. We have angle 3 congruent to angle 4 because of the vertical angle theorem. All right, so if these three pieces are true, and they are, I could actually conclude something about triangles. Specifically, they have triangle JHI, which is the red triangle on bottom, is congruent to the green triangle on top. And let's name this carefully. I called this one JHI, so the top one has to be FJG, or FHG, excuse me, FHG, and that's going to be because of angle, angle, side, triangle congruency theorem. Now, we're not done, because I actually was asked to prove that two side lengths, FH and JH, are congruent. But the triangles they're attached to are congruent, so they have to be. So we can directly conclude from this that FH is congruent to JH because of CPCTC. Corresponding parts of congruent triangles are congruent, which is what that stands for. And guess what, guys? We're actually done. That was a quick one. So I'm going to put a little square there indicating my proof is actually finished. And that's it. That is my entire proof. So once again, I proved triangles are congruent, and because triangles are congruent, the pieces there that are part of them have to be as well, and namely FH and JH, these guys. And I'm done. That's it. The proof is finished. How about that? Not too bad at all, right? One more to go.